Hey everyone, Fernando here. Right now, everybody's talking about AI agents, but most tutorials out there are either too theoretical or they use drag and drop tools where you don't really understand what's happening under the hood. So today we are going to get our hands dirty. I'm going to show you how to build a fully functional multi-agent system from scratch using Python and LangGraph. And we are going to build a smart support system for a bank. So instead of having one confused AI trying to answer everything, we will build a team of specialized AI agents, including a supervisor that delegates tasks and an agent that can actually trigger external tools to check a database. Let's jump right in. So before we look at the code, let's first understand the architecture. So building AI agents is basically like structuring a real company. So as you can see in this diagram, when a user sends a query, it doesn't go straight to a generic chatbot. It goes to our router agent, which acts like a supervisor. So this supervisor analyzes the intent and routes the message to the right specialist. We have the technical agent, a general agent, a billing agent, an escalate node for like angry customers, and an irrelevant node for people asking things outside our scope. Notice that the billing agent has a connection to an external tool. So this is crucial because LLMs can't access real-time bank balances on their own. We have to give them tools to that. Now let's see how to translate this diagram into actual Python code. Alright, so here is our code. We are using LangGraph to build the workflow and Google Gemini's 2.5 Flash as our LLM because it's incredibly fast and great for testing. First, we define our agent state here. Think of the state as the shared memory of our system. So as the user's message travels through the agents, they read and update this state. It holds the user input, the category, and the final response. Next, we have our tool. I created a function called check account balance, and by adding this tool, decorator from LangChain, we are transforming this standard Python function into a tool that the AI can understand and execute. If the agent receives the account number like 1, 2, 3, 4, 5, 6, 7, 8, 9, it will return a balance of 1,500. Otherwise, it says like not found. Now let's look at the brain of our operation, the router node. So this is a standard LangChain prompt. We tell the AI like you are a supervisor, classify the user query into exactly one of these categories. So a pro tip here is that notice that this instruction at the bottom, we have this critical session. So respond with only the exact category word. So when building routing agents, you must force the LLM to output clean data. Otherwise, your code will break when trying to use that word to direct the flow. And next, we have our worker agents, the technical and general agents. They are pretty straightforward, just simple prompts. So you are a technical support agent, guide the user to solve app website issues politely, and the general agent, you are a general support agent, answer general banking questions concisely. But the most interesting part is the billing agent node. So here we are using the LangGraph's create react agent. We do this because this specific agent needs to act, to observe, and to react. We pass our check account balance tool to it, and we literally tell it if the user provides an account number, always use the tool to help him. And finally, we have our escalate and irrelevant node These are not agents. We are not calling an agent API key. We are just giving a fallback. So if the user is angry, we are saying that we are transferring to a human agent, and if the user asks irrelevant things, we just say that we can only assist with bank-related queries. And finally, we bring it all together. So this is where the LangGraph shines. We initialize our state graph, and we add all our Python functions as nodes here in the graph. So we set the entry point first as our router. So it will start by our supervisor, and then we use these add conditional edges to say that, hey graph, look at this category and chosen by the router, and based on that word, send the workflow to the correct agent. So after the specialized agent does its job, it goes to the end. So we have also this add edge to the end of the graph. And okay, so enough theory. Let's run this and see in action. So I have a list of test queries here covering all the scenarios. Let's execute this script. Okay, so here I will simply run our Python file, and it will start with this message. And I will first do the first test, which will be something to redirect to the technical agent, maybe like do something like this. How do I reset my mobile app password? So here, as you can see, the router correctly classified it as technical, and the agent provided a step-by-step guide to reset the app. So this is perfect. So let's test another query. So can you check the balance for account number 1, 2, 3, 4, 5, 6, 7, 8, 9? So this is where the magic happens. So it also correctly chooses the category of billing. So it is going to our billing agent. And here you can see that the billing agent realized it had an account number. So it decided to trigger our Python tool and fetched our data and replied our balance is 1,500. Okay. So let's go to the next one, something like this. I am extremely angry. Let me talk to a human. So also the router caught the sentiment, and it classified as escalate. So it is smoothly transferred to a human abstraction. And going to the next one, let's ask something that is not related to our system. Maybe, what is the capital of France? And the system also successfully chooses the category of irrelevant, and it blocked and kept the AI strictly inside its bank persona. And there you go. In just a few minutes, we built an AI architecture that is robust, modular, and ready to be connected to a real front end. One final thought: if you are putting a system like this in production, never deploy it blindly. So you need to implement evaluation and monitoring. And tools like LangSmith are really great for this. It allows you to trace exactly what each agent is thinking in real time to avoid hallucinations. And if you find this video helpful, hit the like button and subscribe, and let me know in the comments what kind of AI agent we should build next. Thanks for watching.